Okay, now we're going to go from names to structures and structures to names. Really working more with line structures from here on out. Okay, so draw each of the following using line formulas. So we have butane, which is 4, and then bromo means bromine, right? So for A, we're going to go 4, 1, 2, 3, 4. And then on carbon 2, because that's the number over here, we're going to put a bromine. So we're going to go 1, 2, here's 2. And I just draw a line down. If I left it like this, it would be a methyl group, but because it's not a methyl group, I'm going to put a BR there. Okay. All right, 2. 2-chloro, 2-methyl propane. Propane is 3. Methyl, remember, is just 1 carbon. Chloro is Cl. So I'm going to draw over here, B. Now you could do this a couple of different ways, but go 1, 2, 3, right? So if I look, 1, 2, 2 is where I'm going to have something come off of. In this case, I have actually 2 things that come off of the same atom. So I'm just going to extend it out, and it's kind of going to look like an X, right? And so one of those is a chlorine and the other is a methyl. So we just leave it. So that's how we do it if it's a methyl. Okay, C, 2,2-dimethyl hexane. So hexane is 6. And then we know the methyl is 1 carbon, but we're going to have 2 of them. So I'm going to count 6. 1, 2, 3, 4, 5, 6. And I'm going to go to 2, 2, which means on carbon 2, I'm going to have 1 methyl, and then I'm going to have a second methyl. And that is 2,2-dimethyl hexane. Okay, let's see. And then I wanted to do, let's see here. So sometimes you're going to get them as in different formats, right? As more structural formulas. So my suggestion is you can either name it as it is, or you can draw the line diagram and then name it. Some of them are easier than others. So here, regardless, you have to count your carbons. So either I can start from the end close to the A, or I can start from this end. And for this one, it really doesn't matter, because if I do this 1, 2, 3, I'll get a 3, but if I go from the other end, 1, 2, I still get a 3. So it doesn't really matter. So we'll just leave 3, 4, 5, and then coming off of carbon 3, I have a methyl group. So this one's going to be 3-methyl pentane. And if you like, you can draw the line diagram, first. So I need 5, 1, 2, 3, 4, 5, and then coming off of 1, 2, 3 is a methyl. So whatever works for you, right? Just make sure that you're trying to find the longest chain possible, and then give those substituents the lowest numbers possible. So for B, if I start counting 1, 2, 3, 4, 5, 6, I would have a substituent at 2 and 1 at 5. If I went the other direction and went 1, 2, 3, 4, 5, 6, I'd again have 1 at 2 and 1 at 5. So in this case, you could have gone either way. So I have my main chain, and then I have 2 substituents, 1 at carbon 2, 1 at carbon 5. They're both methyl groups. So if I were going to write the name, I would write this name as, I have 2 of them, so be careful with this one. I want to say 2, 5, because that's where my methyl groups are. I have 2 of them, so I'm going to call it dimethyl, and then I need to name the parent chain. The parent chain is 6, so that is hexane. Okay, all right, now be careful with this. You're looking for the longest main chain without picking up your finger, and start at the nearest substituent. All of this is one continuous carbon chain. So what I'm going to do is, I know bromine is a substituent. So I'm going to give this carbon 1, 2, 3, 4 I'm not picking up my pen. 5, 6, 7. That's one continuous chain. Okay. So now I'm going to name it. The bromine here, it's attached to carbon 1. So I call this 1-bromo, right? And then what's 7? Heptane, right? Okay, look at D. Again, we look for that longest continuous chain that's going to give our CH3, well, it's going to give our substituents the lowest number possible, because I see that I have a chlorine here. And now I got to think about what's going to happen with that chlorine and what it's going to be attached to, and what else is going to be a substituent versus a main chain. I want my main chain to have the largest number of carbons possible. So if I do this, right, I'm going to do 1, 2. I could go down and get 3. I could go and get this carbon. I could go to 3. But now what happens with that chlorine? How is that chlorine really attached? So what I want you to do for this one is I actually want you to draw the stick diagram for this one. So this carbon right here, if I start with that carbon is only going to have 2 hydrogens attached to it, right? So if I do that, I'm going to attach it to this carbon here and 2 hydrogens. So I have to have, that's one carbon, that's the other carbon. So where's my 4th bond? My 4th bond is going to be chlorine, right? Okay, so if I keep drawing, I've drawn this first carbon, I've drawn the chlorine, I've drawn that carbon. Now I need to go on to carbon 2. What I have listed here is carbon 2 and carbon 1. And then I have a methyl group coming off of there. So be careful that you realize where the chlorine and where the methyl groups really are. So we want to number our carbons. So we're going to number them 1, 2, 3, 4 to give the substituents the lowest number possible. Because if we went from the other direction, it would give you higher numbers. So now we're going to go ahead and name it. And we're going to say that this is 1-chloro. And then we have a 2-methyl. And then because it's 4, it's bute. And it's carbon-carbon single bond, so it's butane. 1-chloro, 2-methyl butane. Did I do that right? Did I put, no. I think I put my methyl in the wrong carbon. Let me count. 1, 2, 3, 4. Oh yeah, I did. Look at me. As I'm looking at that. Okay, so let me erase. So what I did, just wasn't paying attention. So I have, let me erase the numbers on this so that we can get this right? Okay. So we're going to go 1 carbon, right? And it's got the chlorine attached. That's my 2nd carbon. Here's my 3rd carbon, and there's my 4th carbon. So my 3rd carbon is where the methyl, comes off. So I don't have to label that. So that turns that 2, into a 3. So 1-chloro, 3-methyl butane. Always good to number and double check. All right, let's see. I think I have one more that I'm going to do here. So give the IUPAC name for each of the following. So now we're going to convert from the structure to the name. So again, you can leave this in this format. You can turn it into a stick diagram and then name it. It's totally up to you. It just makes so much more sense to me to put it in a stick diagram. So I'm going to look at my carbons, and I'm looking for my longest continuous chain of carbons. 1, 2, 3. If I started with the 3 as 1, chlorine would still be attached to carbon 2, so it doesn't really matter, right? So my substituent here is the chlorine. So if I'm going to name this, it's a 3-chain long, so that's a propane. Tells me my parent chain is 3 long, and then attached to that 2nd carbon, I have a chloro group. So LORO, chloro, 2-chloro propane, right? Okay, let's look at B. B, I'm going to go 1, 2. What is this thing in here? It's an iodine. Oh my gosh. So that iodine is attached to carbon 2 because you see carbon 2 only has 1 hydrogen. So it has to be attached to carbon 1. It has to be attached to carbon 3. It's got 1 hydrogen and 1 iodine. So that soaks up all 4 of its bonds. And then we have carbon 4. So now I'm going to draw butane. You could do this. You don't really have to do this, but it's okay. So 1, 2, 3, 4, and that gives me butane. Now I have to worry about this iodine. Where does that iodine go? And it's on carbon 2. And so I would just write that. So this would be carbon 1, 2, 3, 4. So I would have 2-iodo butane. Okay. All right, C. Ooh. Do a different color. C. We've got 1, 2. Oh, and be careful with this. This is Br2, 3. So what's actually happening here is that you have 1, 2, 3 carbons, and then coming off of carbon 2, you have 1 bromo group and 2 bromo groups. So it looks like a big X. So if you're numbering this, right, you would go 1, 2, 3. So what do you have on carbon 2? You actually have 2 bromo groups. So you would call it 2, 2 di-bromo. And then you have to name your parent. Me eat peanut. So that's propane. Okay. All right, D. Running out of space. Okay, D. So I'm going to look for my longest main chain. And I see that this is a chlorine. So got to think about this. I'm going to go 1, 2, 3. Or no, actually, I think I want to go 1, 2, 3. That gives me my lowest numbers possible, right? So I'm going to do it with 1, 2, 3 carbons. And that's all I have for carbons, right? Now I'm going to have to put a chlorine on carbon 1. And then on carbon 2, I need a methyl group. So this is 1, 2, 3. So I'm just going to show you in a different color. I'm going to show you, here's my carbon 1 that gets a chlorine. And then my carbon 2 gets a methyl, right? So it looks like, you have to be careful with this because when you're looking here, this right here does not mean it's a carbon. Because I put an element there, it's not a carbon. It is the chlorine, or it is whatever other element it is. So this right here starts your first carbon in the chain, second, and third. So be very careful about that. It's another place where you can get tripped up. Oh, we got to name this sucker, right? Okay, so we're naming this based on the numbering. So we have chlorine and we have methyl. Chlorine is going to come first. So we have 1 chloro. Then we have 2 methyl. And then we have 3, just like before, it's propyl. Propane, not propyl, propane. Okay, squeeze E in there. So in E, when we're looking at E, if we look at our longest continuous chain, that'd be 1, 2, 3, right? And then coming off of 2, we have an iodine and a methyl. So we do the same thing, 1, 2, 3. And then off of that third, we have our substituents. And if you want to do your substituents in a different color, just so it's easier to see, there's your iodine. And here is your CH3, but we don't have to write it. Come on. We just leave it like that. So now we have to name it, right? So if we're going to name it, this is 1, 2, 3. On the second carbon, you got to think, are you going to do iodo or methyl first? Iodo is going to come first. So iodo, then 2 methyl, and then propane. That should all be 1, but running out of room. Okay. All right. I think that's pretty good for now. Okay.